Just scan this QR code for the attendance. All of you scan this QR code for attendance. Scan this QR code. So wait for a minute to join others to join. Yeah. So let's continue. So in the previous class, let me just remind what we discussed. So we are discussing about image enhancement. So first of all, we have discussed why we need an image enhancement. Basically, whatever image we have captured, that is called, we can say, image processing model. Very first step is image requisition. That means we provide an input image. Okay, so once we provide an input image, then we perform an image pre-processing. Okay, that means we have to enhance certain feature of the images. Enhance in the sense of removing the noise or improving the contrast of the image or improving the brightness of the image. Okay, so these things are basically dealt with image enhancement. Okay, how we are performing the image enhancement? The image enhancement can be performed by different enhancement algorithms. It is based upon the specific application. We will apply different enhancement algorithm so that we can improve the quality of the images. So basically, image enhancement is done to improve the quality of the images so that in the higher level application, such as, so if you require a information retrieval or analyze the data, that can be performed better if the image is in better enhancement quality. Okay, so this is the main reason we are performing the image enhancement. Then we have discussed some of the objective of this lecture. Okay, like what you mean by spatial enhancement and what you understand by frequency domain enhancement. Then point operations and marks operations that will be described different types of gray level transformation, then histogram differentiation and frequency domain filtering. Okay, then we have discuss is the broad classification. Okay, the image enhancement can be broadly classified into two different domains. Okay, the first one is your spatial domain. That means whatever enhancement technique you perform, we will perform either in the spatial domain, that is your coordinate domain, that means actual representation, digital representation of image. Okay. The second one we have discussed, second type of enhancement can be performed on the frequency domain. That means either you perform your enhancement, if I say f of xy is your spatial domain, either you perform your enhancement algorithm, whatever enhancement algorithm or technique, either perform in special domain or we can perform in the frequency domain. Let us type UV, type of UV. Now f of UV is your frequency domain representation. Okay. So either you perform your enhancement technique on spatial domain or in frequency domain. Both are same, okay, or both can be permitted. But if you're performing in the frequency domain, then again we have to convert this frequency domain enhancement to the spatial domain by using different inverse transformation method that we have already discussed. Okay, so in the we can say in the broadly we can say the enhancement can be performed in two different domains. One is your spatial domain, where basically we will perform enhancement on the particular pixels. Okay, with particular pixels value पे आप enhancement करते हैं, or we can perform in frequency domain, where particularly we will perform a transform in the particular signals. Okay. Then we have discussed the different types of spatial domain transformation, or we can say enhancement. Fine. So on basically first point you have to remember regarding the spatial domain transform enhancement is, so whatever transformation is we are making on a pixel. Okay. So whatever transformation we make, we will basically make on the pixels. Fine, this is a very important point. So what manipulation we perform on the particular pixels only. And again, the spatial domain is broadly classified into three different type of operation. One is your point operations. Second one is your mask operation. Third one is your global operation. Okay. Then then very first one we already discussed, which is a point operation. Point operation means each pixel is modified by the equation that is not depend upon other pixel value. That means if you are modifying any pixel, okay, the modification or manipulation of that pixel will not be affected by its neighbor pixel. This type of operations is called point operation. The mathematical representation of the point operation you can see here. This is a mathematical representation of the point operation where f of mn is your original image. Okay, f of mn is the original image, or I can say the original pixel of an image. Then we are using a transformer operator. Okay, or we can say T is an operator. Okay, T is an operator that you want to perform. Now this can be a linear operator or a non-linear operator. Okay, now this T can be a linear or non-linear. Okay, whatever you want to perform, whether it is linear perform, you want to perform linearly or non-linearly, you can use this one. So whenever I perform this one, okay, this is my original image, original pixel हम लोग क्या कर रहे हैं, ये अगर ऑपरेटर कर रहे हैं, then I will get a resulted image which is given by your G of mn. Okay, so in this point operation, now what P stands for? P stands for your operator on one pixel. Okay, now this T is basically operator in a single pixel, or we can say there exists a one-to-one mapping. Okay, so if I draw, this is my original image f of mn. Okay, so let me draw the coordinate. Now suppose this is each pixels. These are each pixels. Okay, and suppose this is my g of m, and Now I'm performing certain T operator. Now what will happen? This T operator, now let me show this pixel. Okay, this is the pixels. Now if I say I'm performing this T operator, this T operator will perform on each pixels. Now suppose this is T1 pixel. Now it will perform like T upon, it will perform like T upon pixel T1. So what will you get? Now you will get some T tags. Now it will be this equivalent to this pixel T1 dash. Now what will happen? There is a 1-to-1 mapping. You can see there is 1-to-1 mapping. Similarly, if this is a T2. Now same, what will happen? T is performed on a pixel T2. Then it will give a enhanced image which is P2 dash. Now it will be a P2 dash. Similarly, if it is a P3, it will be a P3 dash. Okay. Similarly, if it is a P4, it will be a P4 dash. So what actually is happening? Now this operator T, okay, is performing on each of the pixels of the image. Okay, and its equivalent resultant pixels are denoted by P dash tab, which is represented in its equivalent coordinate. Okay, but some changes. What changes? The changes depend upon what the T operator you are taking. It can be addition, it can be subtraction, multiplication. Okay, now these are the linear operator. It may be logarithmic, it may be exponential, it may be a gamma function. Now these are our non-linear. This is non-linear. Okay, this T can be linear type or this T can be non-linear type, depend upon what type of operator we are performing. Fine. So this is called point operation. Okay, point operation means हम लोग हर एक पिक्सल पे ही ऑपरेट करेंगे. I hope it is clear to all of you what you understand the point operator. Okay, now moving ahead to the second type of operation, which is the mask operation. Okay, we are studying about image enhancement in spatial domain, and again in spatial domain we are specifically talking about what you understand by the mask operation. So in a mask operation, this pixel is modified according to the value in a small neighborhood. Now what it is saying that now, like in the previous case, okay, that totally depend upon the independent pixel. Here is something different. What is different? Here each pixel is modified. Okay, each pixel is modified according to the small neighborhood. So what happened? So modification of pixel. If you take, suppose let's take an example. Now suppose this is my pixel P. Now if I perform the modification of this pixel P, it's not only depend upon what type of transformation I'm performing on P, but also depend upon what are the pixels that are present in its neighborhood. This is called mask operation. Okay, each pixel is modified according to the value in a small neighborhood, which is called mask. Okay, so in a mask operation, the operator T operates on neighborhood pixel. That means what happens? This T is not only going to perform in this particular pixel, it is going to perform on its neighborhood pixels. So whatever the mask size you define, okay, basically we will define a mask size of 3 cross 3 or 6 cross 6 or 9 cross 9. So it is not only the T operator is not only performing on a particular pixel P, but also it is performing on its neighborhood pixels. Fine. So marks is a small matrix. So what is a mark? The question rises here. What is to understand by the marks? Okay. So marks is nothing but small matrix whose value often termed as a weight. Right. So basically, we will design a matrix type. Like I already said, it can be a 3 cross 3 matrix or 6 cross 6 matrix, and whose value will be obtained as an, we can say it will be obtained as an weight. Okay. And one thing you remember here, each marks has an origin. So whatever marks you define, okay, now each of these marks will have an origin point. And the origin is symmetric marks is usually the center pixel position. Now, if you take a symmetric marks like 3 cross 3 or 9 cross 9, then what will the origin? Origin will be the central part. Okay. So, what are central element that will be decided as a origin. Okay. So, remember this one or for origin for symmetric marks. Okay. Symmetric means if the size, number of rows and columns are equal. So on that case, we can say the center pixel is your origin. And for the symmetric marks, okay, any pixel location may be chosen as the origin depend upon the intent users. Okay, now origin can be chosen by uh, user who is choosing it. Now you can see difference between now. This is basically this diagram shows the difference between the point operation and the marks operation. So if you perform the point operation, now basically the P is performed on a particular pixel P, we are performing the enhancement that we are getting a result. But if you are want to perform marks processing, okay, now first of all you choose the pixel, now consider the marks, then we are choosing the origin. Now when you perform, it will be performed on that mask operation. Now it will not going to perform. Okay, this one, or we can say this called transformation, this image enhancement is not going to perform on the single point. Okay, it is not going to perform in the single point. Rather, it will be going to perform on the neighborhood pixel. That will be, or we can say, mask pixel. Okay. So this is called something about what you call mask operation. Okay. So basically, these two are in force. Okay, one is a mask operation, second one is a point operation. So there is a global operation, but there is not that much of need. Okay, but just note down the definition. In a global operation, all pixel value in the image are taken into consideration. Usually, the frequency domain operation are global operation. So what happened here? Now here we are not going to enhance a single pixel or based on the mask of the pixel. Instead of that, we will going to consider the entire pixel, okay, or entire image. Now here, if you want to perform the image processing, okay, if you want to perform image processing, now what will happen? What will happen? Now instead of taking a single point of pixel or instead of taking a mask pixel, what I will take or what I will consider? So I will consider the entire point. Okay, entire point. And this is called a global operation. Now, enhancements of point operation. Now you can see this diagram basically see so how we are improving the context of image. Okay. Now this is my input image. So I am performing the point operation here. Now this is my actual output image. So in a point operation, each pixel value is mapped to a new pixel value. Now you can see here each of this pixel value. Now this pixel particular value, intensity level of this value is mapped to the exactly the same pixel value, or we can say intensity level of same pixel values. Now, second point, remember, in the point operation, the enhancement at any point depends only on the image value at that point. Okay. Now, whatever enhancement you're performing, it's only depend upon, okay, the image value at that point. Is what is my intensity level of that point. Now, enhancement is basically specific to that point only. We will not bother about or will not consider about its neighboring pixels, or we are not going to bother about what are the intensity of neighboring pixel. But in case of mass operation, the intensity or enhancement of pixel not only depend upon the intensity value of that pixel as well as whatever the neighboring pixels intensity level are there, that is also going to affect in case of your mass operation. And in case of global operation, in the case of global operation, we are considering the whole pixel as an image. Now, whenever performing any enhancement in single pixel, then every pixel intensity will be taken into consideration. Fine. Now it is clear to understand from this diagram the enhancement to the point operation is completely one-to-one mapping. Okay, it is one-to-one mapping. You can say it is one-to-one mapping. One-to-one mapping. Now, if you perform this one, now it will be equivalent to this pixel. Now, you perform this one, it will be equivalent to this pixel. It will be equivalent to this pixel. Right? One-to-one mapping. Okay, I think this is clear to all of you. Okay, so let us discuss first what are different type of point operations. Okay, now we will basically talking about the T operation. T in a point operation. Okay, so first of all, the brightness modification. The first operation is a brightness modification. So as the name suggests, the brightness modification is whenever we want to improve the brightness of an image. Okay. Now, we can say the brightness of an image depends upon the value associated with the pixel of the image. Okay, or we can say what are the intensity level. Okay, what are the intensity level that is associated with that pixel value. Okay, brightness is basically note that one. And the brightness of the image can be increased. How we can increase? By adding a constant value to each and every pixel of the image. Okay, so if you remember what we have done, so when we are converting in digital format, okay, now what actually is present, now it will first of all it will perform a sampling. Okay, so first of all perform sampling, then you perform the quantization. Okay, when you perform the quantization, fine. So when you perform the quantization, it will be assigned certain value. Now these values will be the intensity level. Now suppose I did nothing, right? Suppose that this is a grayscale image. Now the range of this intensity level will be 0 to 255. Okay, the range will be 0 to 255. Okay, so suppose let me assign the values 260, 255, like 210. Okay, so it will assign certain values like this 209, then 212, suppose 189, now 190, 195, 198. Now this values is particularly represent your intensity level of this pixel. The intensity level of the pixel, or I can say the brightness of this pixel. So whenever I want to improve the brightness or increase the brightness, so what I will do, I will add a certain constant value to each of this pixel. Okay, now if I want to improve the brightness of this pixel, so what I will do, I will add certain constant like 50. So what will happen? So I will suppose I say P equal to perform addition of the 50. Okay, now what will happen? Each pixel will be added with the value 50. Now each pixel will modify as, now it has become something 256. Now it will become something 305. Like that, this pixel values is added. Okay. Now, what we're basically doing? Now when we are adding, what we are doing, we are increasing the brightness of an image, or we can say brightness of the image can be increased by adding a constant value to each and every pixel of the image. Similarly, the brightness can be decreased. Okay, the brightness can be decreased by subtracting a constant values from each and every pixels of the images. Fine. So now, like this, we can increase the brightness or decrease the brightness. Now, what type of operation this one? Now, this is a linear operator because once the input image and the output image are linearly dependent. Now, this operator improving the brightness is nothing but your linear operation. Fine. So that this is an example how to increase the brightness of the image. It's very simple method. We can say a simple method to increase the brightness of the level, brightness value of the image is to add a constant value to each and every pixel. Okay. Now, for example, if f of mn represent your original image, then if g of mn represent your enhanced image, which is obtained by a constant value k, then the mathematical equation that will be given as, or this is my mathematical equation. So what is this one? This is my obtained image or enhanced image, which is obtained by adding a constant values. Now this value constant k to the original image. So what it will do? It will add a constant value k to each and every pixels of this f of mn. Fine. So in this way, we can improve the or we can increase the brightness of the images. Fine. Similarly, we can increase the brightness also. So what will be the? Let me clear this one. Yeah. Similarly, what we can do? We can uh, decrease the brightness also. So what will the mathematical formula for that one? Now, if g of mn represent your obtained image. Now, if f of mn is my original image, so I will subtract a constant value k. I subtract a constant value k from each and every pixels. So whatever we obtain, it will be your decreasing brightness of the images. Okay, it will be decreasing brightness of the images. Fine. I hope it is clear to all of you. The first operation. Okay, but we are talking about the different types of operation. On this, we first we discuss the brightness modification, which is your linear operator. It is very simple. We can add a constant or subtract a constant to get an enhancement. Fine. Now this is an example you can see in this example. Okay. So this is my. You can see we have used the picture of an eye. Okay. Now this is your original image. Fine. This is our original image, which is captured. Now what we need? If you observe that the original image has suffering from low brightness. What will happen if you provide this image as for the image people or as for the image acquisition, okay, for the higher stages. So when you when we want to analyze this image, okay, so it may be case that we will not get a proper data. Okay, for that, what we have to do before providing this image for analyzing stage, okay, what we have to do, we have to perform certain pre-processing. So what pre-processing is performing there? Now what I will do, I will improving the brightness. So here what we have done, we have improved the brightness. Now you can clearly see the enhanced image in the right hand side of the screen. Now this is my enhanced image. Okay. Now you can clearly see the difference between these two images. The enhanced image is much brighter. Yes or no? It is much brightness. It is having a much brightness as compared to the original. So how it is obtained? So here in this case, we have chosen the value of k equal to 50. Okay, the value of k which we have chosen to the 50. So what happened? Now this 50 is added. Okay, Okay, this 50 is added to the each pixel value of the original images. Fine. Okay. So there is a one problem here. So if it is a grayscale image, okay, if there is a grayscale image, so what is the range? I already said. So how many bits are required? We require 8 bits. Yes or no? So what is the range? The maximum we can store it is 0 to 255. Fine. Now let us consider a case. Now suppose if you are having an image like this. Okay. Now this is my image pixel. Now suppose consider all these values are more than 240. It's about 240, 241, 245, okay, 256, 55, 225, 222, okay, 232, 232. Now, what happened now when I will add a constant value k here, okay, so what will happen? All this modified pixel value will be like, what will happen? Modified pixel value of 50 is added to everyone. Now what will happen? Now it will be something 290, it will be 305, it will be 295, it will be 305, it will be 305, it will be 272, it will be 282, it will be 282, and it will be 284. Now you can see here, you can see if you observe here, what happened? So as we have said the grayscale image, the output also is grayscale image. But if you observe that the range of the grayscale image is 0 to 255. But what value are we storing? Now every pixel value is greater than what? It is greater than 255. Can I store this 255 here? Greater than values? No, it is not possible. We cannot store. Okay, as it is a grayscale image, we are using only 8 bits. The range of the intensity level should be in between 0 to 255. So what solution we will have? What solution we will have? I cannot store this value. So with two methods we will going to use here. If the range is going to exceed, the two methods we are going to use here. One is called a clipping. Okay, one is called a clipping. Second one is scaling. Okay. First one is your clipping method. Fine. Or second one is called your scaling. So we will discuss these two methods. If the range goes beyond that one, okay, if the range goes beyond this one, so we're not able to store these values. If you're not able to store this value, how it's possible? We should have certain procedure for that one. And the name of the procedure is called either we will use clipping or we will use the scaling technique. Fine, so we will discuss this too. So I think it is clear to all of you how we are improving the brightness. Okay, I think it is clear to all of you. Similarly, we can use second operation, which is called your decreasing the brightness. Okay, Now brightness can be decreased in the same manner. Okay. Now in this case, instead of adding the constant, we will subtract the constant value. Okay. Instead of adding the constant value, we will subtract the constant. Now here you can see the formula is g of mn equal to f of mn minus k. Now it is clearly absorbed in this image. Now this is my original image and this is the enhanced image. Fine. Now here what we have done, we have decreased the brightness. Now the value of the cube we have taken as 7. Okay, so I'll stop here class and we'll continue in the next class.